Good day, grade 12. So for today's lecture, we would be discussing Newton's Universal Law of Gravitation, our lecture number 2 for quarter 2 on General Physics 1. So for today's lecture would be focusing more on this most essential learning competencies. Okay, to start off with our topic, do you know the story behind Newton and the apple? So on a lazy afternoon, Newton was taking a sip of tea on his mother's garden under a apple tree, and then suddenly an apple fell off above his head. Okay, so this phenomenon has greatly affects, okay, what we know about gravity, okay, based dito sa story ni Newton at saka nung apple na nalaglag sa ulo niya. Okay, so he thinks that this apple, that some way or another, this apple, okay, is pulling the earth, okay, toward itself, and the earth is pulling on the apple. That's why meron tayong concept of gravity, that everything, okay, is attracted towards the center of the earth. Pero hindi lang yung earth yung may attraction sa lahat ng body, okay, over it. So yung mga body na yon, okay, meron ding attraction papunta sa earth or pabalik sa earth. So dito na discuss ni Newton yung concept na yon sa Newton's Law of Universal Gravitation. Okay? So on Newton's Law of Universal Gravitation, he states that okay, the apple was attracted to the earth. Okay? And all objects on the universe were attached to each other in the same way the apple was attracted to earth. So hindi lang na limit si Newton sa apple and the earth. He thinks of ano kaya yung mga planets kaya attracted din kaya sa earth? Yes. So na-prove po 'yon ni Newton sa kanyang Newton's Law of Universal Gravitation. So it is also stated in this law that all objects attract each other with the force of gravitational attraction and what we know as gravity. So, gravity itself is universal. Okay? So, Newton's law of gravitation states that every particle in the universe attracts every other particle with a force that is directly proportional to the product in the masses and inversely proportional to the square and the distance between them. Okay? So, ito po yung mathematical expression ng statement na to, where F, we're talking about the force of attraction between two objects is equals to the G constant, okay, multiply by m1, m2, and divided by the distance between them. So for the two bodies to attract with one another, in order for us to compute the force of attraction between two bodies, okay, so we use this equation formulated by Newton. But okay, the G part here is just the constant value. Okay, hindi pa to alam dati. Okay, hindi pa to alam dati ni Newton. Okay, na ano niya lang to, nilagay niya lang yung G as a placeholder. Kasi, tingin niya, okay, kailangan magkaroon ng relationship between M1 and M2 and over R squared. Okay, yung maliit na value ng relationship na yun. But later on, okay, may naka-discover, okay, ng value ng G. Okay, G is what we know as the constant of universal gravitation, and it is equals to 6.673 times 10 raised to negative 11 Newton meter squared over kilogram squared. So it is determined experimentally by this uh, device made by Henry Cavendish essentially a century later, after Newton have discovered the universal gravitation. Okay, so if we're going to look at your calculators, okay, so go to your calculator, so you could key in the value of G, okay, to your calculators by pressing shift 07 or shift constant, and the value of G is number 39. So that is how we place this shortcut to our calculators. Okay? So later on, yan, meron na tayong value ng G, and it is constant with this specific amount. Okay? So, the Newton's law of universal gravitation, sabi natin, meron tayong dalawang forces dito or dalawang masses na nag-a-attract dun sa isa't isa. Okay, so the force that mass 1 exerts on mass 2 is equal to the opposite of the force mass 2 exerts to mass 1. Okay, so the forces form a Newton's third law of action-reaction, whereas, okay, the other exerts action force and equal and opposite reaction. Okay? So, under din po siya or masasatisfy din ng Newton's law of gravitation yung naunang na-formulate ni Newton with his laws on motion. So, the gravitational force exerted by a uniform sphere on a particular outside the sphere is the same as the force exerted if the entire mass of the sphere were to concentrate or were we concentrated on its center. Okay? So, kailangan, yan, makita natin, okay, yung difference ng body, okay, with its mass and their difference sa distances para makita natin how much is this body attracted on to one another. Okay? So, this law of Newton, okay, mathematically, the Newton's law of universal gravitation. So we state that F, okay, is equals to G m1 m2 over r squared. Okay? So this also have, okay, a relationship with the free fall acceleration or what we know as the acceleration due to gravity. Okay? So, paano ba natin na-compute or paano ba natin na-derive na ang value pala ng acceleration due to gravity, small letter g, is equals to 9.81 meters per second squared. Okay, so dito yan. Okay, dito yan nagmula kay gravitational force or sa equation ng gravitational force from Newton. Okay, so we know that on the Earth, okay, kasi ang basis natin dito ay sa Earth, okay, so para makuha natin yung force ng any object on Earth, we use this equation. So, G, okay, our gravitational constant, yung mass ng object sa Earth, for example, meron ka ditong box, okay, so yung mass ng box na yon sa Earth, M, and then, since hinahanap natin yung force of attraction nitong box towards the center of the Earth, so you have to also get the mass of the Earth. Okay. Divided by, since itong object natin, pwede nating sabihin, sige, nasa ground siya. So, meaning nandun siya sa surface ng Earth. So, ang distance niya towards the center of the Earth is its radius. Okay? So, RE. So, ano po ba ang mga value ng mga to? So, ME or mass of Earth is approximately equal to 5.9742 times 10 raised to positive 24 kilograms. And the radius of Earth approximately is equals to 3781, okay, times 10 raised to positive 6 meters. Okay, so if we're going to substitute this equation, yan, dito, tapos, since F is equals to MA, yan, equate natin, F is equals to MA, we're going to get, diba, the value of the acceleration due to gravity. So, equate natin yan dito, G is equals to ME over r squared. Okay? So, if we're going to divide both sides by M, yan, makakancel yung M on this part, leaving us the equation of AG, okay, which is equals to G ME, okay, r squared. So, meaning sa Earth, okay, or when you're going to find the acceleration due to gravity sa ibang planets sa solar system, pwede nyo lang paltan yung mass ng Earth dito and you could get the, okay, the A or the free fall acceleration on that specific planet. Kasi if we're going to substitute these values to this equation, you'll be getting AG or G na lang, small letter G, which is equals to 9.81 meters per second squared. So, this is the basic equation for free fall acceleration or acceleration due to gravity on Earth that is also applicable on the acceleration of gravity on any other planets or celestial body on the solar system or the universe. Okay? So, ganun ka-broad, okay, yung mga laws na na-formulate ni Newton that is also applicable, it is not only applicable to the Earth but also on the entire universe. Okay? So, since we're talking about here, uh, any moving body, okay, sa universe, okay? So, any moving body has its own energy. So, may energy conversions po tayo dyan. But basically, since we're talking about Earth and the gravitational field of an object, okay, meron po yung potential energy. So, we know that the basic equation of gravitational potential energy is equals to U mgy. So, it is only valid if the object is near the Earth's surface. So how about it is not, okay, or it is at a specific altitude. Okay, so we use, okay, this equation, u, where is it states that it is our value for gravitational potential energy is equals to negative g mass of the Earth, mass of the object divided by the distance between that object and the Earth at a specific height or altitude. So for objects with high above the Earth's surface, an alternate expression is needed. So we could also look on the equation. We notice that the equation is on the negative part because it is the body above, okay, the Earth is pulling it down to its center. Okay, how about the acceleration due to gravity when it is at specific height or altitude? Okay, paano natin kukunin yan? Okay, so 'di ba alam natin yung equation natin ng AG kanina is G ME, okay, over R squared. So, since nadagdagan yung distance niya, okay, sa Earth, wala na siya. Okay, wala na siya sa surface, itinaas na natin siya. So, yung distance between that object, okay, with respect to Earth would also increase. So, you have to describe that phenomenon using, okay, on your equation. So, AG would become GME, okay, and then R squared plus H, where H is your height with respect to the surface or above the surface of the Earth. Okay, so that is for gravitational potential energy. Okay, next we have Kepler's law. This law was made before, okay, years before the Newton's universal law of gravitation. Okay, so ang isang goal kasi ni Newton is to prove Kepler that Kepler is wrong or that Kepler is right. Okay, but okay, since universal nga itong law ni Newton, later on, na-describe nila, ay, tama pala si Newton kasi nag-a-agree siya dito sa Newton's or nag-a-agree siya kay Kepler sa tatlong laws ni Kepler, specifically on Kepler's third law. Okay? So, meron tayong tatlong Kepler's law. So, Kepler's first law states that all planets move in elliptical orbits with the sun at one focus. Second law states that a line drawn from the sun to any planet will sweep out equal areas in equal times. And the last, the square of the orbital period of any planet is proportional to cube of the average distance from the sun to the planet. So how does that sound like? Okay, so let's take a look on this.
According to Kepler, the orbits of the planets were ellipses, as opposed to circles, with the sun at one focus of the ellipse, one of the two central points used to describe how the ellipse curves. And that's what's known as Kepler's first law, and it actually applies to any elliptical orbit, not just those of planets. Our moon's orbit around the Earth is also an ellipse, and Earth is at one.
Okay, so on Kepler's first law, he stated that all planets move in elliptical orbit. So lahat po ng mga celestial bodies, even the moon, okay, moves around in an elliptical manner. Okay, where their focus is at the sun. Okay, second law.
At its farthest point from the sun, for example, over the course of one day, will have covered an area that looks like a very long, very thin, kind of lopsided pizza slice. And when we're at our closest point to the sun, one day's worth of orbit will sweep out an area that's more like a short, fat pizza slice. Kepler's second law tells us that if we measure them both, those two pizza slices will have the exact same.
Okay, so based from this video, so you could see that you have two slices of pizza here, but the center is with respect to the sun. Okay, so this thin uh pizza here, okay, if you're going to differentiate it on our very large or thick uh pizza here, the area of these two pizzas would be the same, okay? Because the line drawn from our sun to any planet will sweep out equal areas on, okay, equal times, okay? And then last law.
A little more technical, but it's basically an observation about what happens when you take the longest or semi-major radius of a planet's orbit and cube it, then divide that by the period of the planet's orbit squared. According to Kepler,
Okay, so based from this third law, the square of the orbital period on any planet is proportional to the cube of the average distance from the sun to the planet. Okay, so mathematically speaking, it is just t squared, where the period of your planet is equals to k, where k is for the orbit around the sun, or ks, which is equals to the value of 2.97 times 10 raised to negative 19 seconds squared over meter cube. So we derive the value of ks, which from the universal constant, okay, and the mass of the sun. So it is equals to 4 pi squared over g, or universal constant or gravitational constant, and then multiply by the mass of the sun. Okay, so dun lang natin na derive yung value, okay, ng equation for Kepler's third law. So now let's take into practice the equations we have noted from this presentation. So we have here, calculate the force of gravity that exists between a 60 kilogram person and an 80 kilogram person who are 50 centimeters apart. So let us illustrate the problem. So we have here our first person who weighs 60 kilograms and the other person, which has a mass of 80 kilograms. Their distances is, 50 centimeters. Kapag kinonvert natin yan sa meters, it is 0.5 meters. Okay, since ang hinahanap natin sa force of gravity that exists for these two, person, we use equation gm1 m2 over r squared. So, g times 60 times 80, divided by 0.5 squared. So, you'll be getting force is equals to 1.28 times 10 raised to negative 6 Newton. So, that is for our first problem. So how about this one? Calculate the net force exerted on the moon, which has a mass of 7.35 times 10 raised to 22 kilograms when it's between the Earth with a mass of 5.97 times 10 raised to negative 24 kilograms and the mass of the Sun, which is 1.91 times 10 raised to positive 30 kilograms. The distance between the moon and the Earth is 3.84 times 10 raised to positive 8 meters. The distance between the sun and the moon is 1.492 times 10 raised to positive 11 meters. So to fully imagine what is the problem is pertaining to, mas maganda kung i-drawing natin or illustrate natin yung ating scenario. So we have here the sun, and they are aligned at nasa gitna daw nila yung moon. So, basically, ang nangyayari dito sa problem natin is meron tayong eclipse, parang solar eclipse. Okay, kasi align in one, or in a horizontal line yung ating tatlong celestial bodies. This is Earth. Okay, so, since ang hinahanapan natin ng force or net force is the moon, Okay? So, magfo-focus tayo or magko-concentrate lang tayo muna kay Moon. Okay? So, si Moon, yan. So, si Moon, nag-exert yan ng effort or nag-exert yan ng force kay Sun. Okay? So, let us call that force Fs. So, papunta siya dito. And then, si Moon also exerts force kay Earth. Okay? So, para makuha natin yung net force, okay, at the Moon, okay, since nakikita natin opposite yung direction nitong dalawa, okay, so Fs, uh, let's start off with Fe kasi positive yung direction niya, Fe minus Fs. So, para makuha natin yung Fnet dun sa point Moon natin. Okay? So, compute muna natin yung mga values. Let's start with Fe. So, Fe is G or the force between mass ng Moon tsaka ng Earth natin divided by the distance between the Moon and the Earth. Okay, square. So, let's key in the values. So, the mass ng Moon is 7.35 times 10 raised to 22 kilograms multiply by mass ng Earth 5.97 times 10 raised to 24 kilograms, and we also have the distance between the Moon and the Earth, which is 3.84, okay, times 10 raised to positive 8 meters. So, key in sa calcu, we would be getting the value of Fe, which is equals to 1.985, okay, times 10 raised to positive 20 newtons. Okay, how about Fs? So, this one, this force. So, G, mass naman nung Moon again, and then mass nung Sun, and the distance between the Moon and the Sun. Okay? So, Fs is equals to G. Yan. So, ang mm natin is 7.35 times 10 raised to 22. The mass of the Sun is equivalent to 1.99 times 10 raised to positive 30, okay, kilograms, over the distance between them is 1.492 times 10 raised to positive 11. So, we'll be getting a value of Fs, which is 4.383, yan, times 10 raised to positive 20 newtons. Okay, so pwede na natin siyang i-calculate using this equation. So, let's start with the Fe. 1.985 times 10 raised to positive 20 minus a force between Moon and the Sun, which is 4.383 times 10 raised to positive 20. So, you'll be getting here a value of negative, okay, negative 2.398 times 10 raised to positive 20 newton. So, why negative? Kasi, okay, the force between the Sun and the Moon has greater value because the Sun has greater mass compared to Earth. Okay, so Fs is greater than Fe. So, during an eclipse, mas attracted yung Moon kay Sun with comparison or comparing to the Earth. Okay? So, that is for this problem. Next, calculate the net force exerted on the Moon. Okay, same mass by the Earth. Okay, same masses din in the Sun when the two gravitational forces acting on the Moon are right angles to each other. So, dito, this is just the same as our previous problem, but the orientation or the placement of our bodies is different. So, let us illustrate, okay, the given. Okay, so let's start off with our Sun. So, kunwari, dito yung Sun natin. Tapos, yan, nandito yung Moon natin. Tapos, yung Earth daw natin is at the right angles to each other. Okay, so itong Sun and Earth ay naka-right angle sa moon natin. Okay, so ito yung distance ng R, S sa M. Tapos ito yung distance ng, okay, R, M sa E. Okay? So, dito, since ang atin ulit ay point of concentration ay sa moon, so sa moon lang tayo titingin. So, sa moon, meron siyang force, okay, attraction papunta sa Earth, okay, Fe. Tapos, si moon also, may force attraction din siya papunta sa sun. Okay, so since same lang din naman yung point of concentration natin, so same lang din yung magiging value, where Fe, katulad nung sa previous nating problem, which is equals to 1.985 times 10 raised to positive 20 newtons. And then we also have a value of Fs, which is equals to 4.383, okay, times 10 raised to positive 20 newtons. Okay? So, but since yung orientation ng moon natin ay magkaiba, so magkaiba yung magiging way natin ng pagkuha nung Fnet. Okay? So, recall kung ano yung na-discuss natin sa vectors. Okay? So, try natin yung vector illustration, yung end-to-end. So, let's start with um, our Fs here. And then, we have here our Fe. Yan. Tapos, ito yung magiging itsura nung Fnet natin. Okay? So, since dito, right triangle siya, yan. So, meron tayong perpendicular value. Fnet mo, yung value ng hypotenuse mo. So, paano mo ba makukuha yung value ng hypotenuse? So, you're going to use the Pythagorean theorem, where Fnet is equals to Fe squared plus Fs squared. Okay? So, square root ng values ng Fe natin, which is 1.985 times 10 raised to positive 20 plus 4.383 times 10 raised to positive 20 squared. Okay? So, we would be getting our value of Fnet, which is equals to 4.812 times 10 raised to positive 20 newtons. Okay? So, this is how we do or how we calculate Fnet when the orientation is just like this one. Okay? So, since force is a vector quantity, okay? So, we have to apply our rules on trigonometry. Okay? So, since dito, hindi naman sinabi dun sa problem natin, hanapin natin yung um, uh, direction ng ating force vector kasi hindi naman natin alam kung saang orientation ba yung right triangle. Nag-ano lang tayo, nag-conclude lang tayo na nandito lang pa sa taas. Pero pwede rin na nandito yung E natin. But if we're going to, or the problem or the question is looking for, okay, the angle or the direction of our force vector, so we'll be using this equation again, tangent negative 1, okay, F E over Fs. Okay, so dito kasi hindi pa natin alam, di pa tayo sure kasi pwede rin siyang nandito yung E. Okay? Either way, so pwedeng positive or negative na lang yung maging values ng ating angle. But make sure that your angle of your final angle would be reference to positive x-axis. Okay? So that would be all for this lecture about Newton's law of universal gravitation. Okay? So that would be all for this lecture. I hope you had a great day ahead of you. Stay safe, stay hydrated, and stay sanitized. Goodbye, and thank you, class. See you again next lecture.